Hello, I'm John Keever, CTO of Telit Platforms. Welcome to this edition of the Telit Coffee Connection series. I have my coffee and I hope you have yours too. Our topic for today is common IoT prototyping hurdles. IoT solutions, by their very nature, present a broad collection of challenges because there's so many moving parts. At the highest level, you have all the hurdles of classic project boundaries to deal with. You have cost, you have schedule, you have time, you have resource, you have focus, you have flexibility. At the end of the day, everything is a trade-off and a balance. At the lowest technical level in IoT, though, we have all manner of details to grapple with. There's numerous hardware components to consider: sensors, processors, communications modules, network systems, security. And then at the software side of the fence, you also have firmware, physical interface, security, applications logic, connectivity management, device management, platform functionality. And when you get to the cloud side of the equation, you got big data, data archival, analytics, and visualization. The fun never stops. IoT is a complex end-to-end tapestry when you weave a solution together. And the challenge of prototyping brings it all together. At each one of these topics in itself is a study. It's a science. There's no question that prototyping is a necessary part of most any IoT solution deployment, large or small. Prototypes serve as a reality check to us where signals meet logic and reality. They force us to grapple with the details that are all too easy to assume away during conversations and high-level designs. Most IoT-oriented solutions fall into two basic categories: purpose-optimized edge device-centric or gateway aggregation-centric. Edge device-centric solutions will tend to be based upon small footprint, chip-down designs. Gateway-centric applications, on the other hand, will tend to be based on off-the-shelf gateways and connected sensors and actuators. In either case, you're almost always challenged with sensing the physical world in which we live and then interacting with mankind in some way, whether it's a user interface, a database, an analytics system. It's the value that IoT brings to the table. Sensor selection is critical, as not all sensors are created equally. The user must consider everything from the nature of what they're sensing to the physical footprint and behavioral characteristics of the sensor itself. How small is it? How large is it? How much energy does it consume? You have to consider resolution, accuracy, hysteresis, signaling, and more to take all of these things into account to solve the problem that you're aiming to address. This goes for sensors large and small as well, connected and integrated. Whether you're at a board down or chip down design at the SPI level or I2C level, or at a gateway level where you're connecting to Ethernet attached or wireless sensors. Once we have decided how to sense and what we're going to sense and we're ready to move on, we have to consider the actual way we're going to process the data we receive. Are we going to use a microcontroller level processor, or are we going to go to a full-up application processor? The overall scale of the project and the endpoint cost details have to be taken into account. One of the greatest challenges of IoT prototyping is creating a viable representation of the target product design in the most accurate way possible for the lowest possible cost. So lots of challenges come to bear when you start putting together that IoT prototype. One challenge of the edge sensing and processing is addressed, then you get to deal with the communications mode or modes that are going to be used. This can range from wireless sensing over Bluetooth, Zigbee, or LoRa to low category LTE wireless connectivity using CAT-M or NB-IoT. Either way, the IoT prototyping effort has to find a way to make the connection and communicate as the end-to-end solution ecosystem is realized. For industrial-oriented IoT, the application of off-the-shelf gateways with support for native protocols of industrial and commercial sensing and actuation is imperative. You have to have it. In gateway-based design, sensory control actualization is a primary order of business and has to be treated as such. In chip-down purpose-optimized designs, it could be data accuracy and battery life as the key design points, and they would have to be treated as such. In some cases, the overall bill of material can be reduced and cost-optimized by using the communications module as the applications processor as well. It allows you to reduce that bill of material and reduce your overall cost. Telit has partner products and provides hardware kits and platform evaluation trials to help simplify and accelerate your IoT prototyping efforts. We hope to take some of those hurdles out of the way so you can move faster, quicker, at a lower cost and get where you need to go. At the gateway level, Telit works with a number of gateway vendors to provide rich function off-the-shelf gateway products. For lower-level chip-down development efforts using telecommunications modules, our EVK2 evaluation kit allows developers to access all the signals available from our wireless modules. For rapid edge device prototyping for IoT solutions, the Telit Bravo board supports pre-integrated sensors and plug-and-play integration with maker platforms like Arduino and Raspberry Pi, and it includes our award-winning Telit ME910 One-Edge module. That was a quick review of common IoT prototyping hurdles. If you want to learn more about this topic, please feel free to schedule a meeting with us. Thanks for joining us today for this edition of Telit Coffee Connection Series.